Stop. Hello and welcome to this lecture. Today I will discuss the testing of significance. So in the last class we have defined some terminology which is used in testing of significance. So I start from test of significance, or you can say test of hypothesis. So what is hypothesis? Hypothesis is any statement about the population. So if we have the population and if you say something about the population, that is nothing but the parameter, and the parameter, if you say any statement about this population, and this statement is known as hypothesis. So to validate this statement we just take a sample. A sample is a part of population. So this is the population, and this is the sample. Sample is taken from the population. Now we have to study this sample, and from this sample we have to validate the hypothesis whether the statement given about the population is true or not, whether this sample support the statement about the population or not. So the hypothesis, there are two types of hypothesis. Generally we take the null hypothesis, and second one is the alternative hypothesis. Null hypothesis is denoted by H naught and alternative hypothesis denoted by H1. The null hypothesis means no difference. If we just compare the population parameter and sample statistics, the null hypothesis means there is no difference between the parameter and our statistic. If there is difference, then we can say this is the alternative hypothesis. So we in null hypothesis we just go with the population parameter, and this is written as H naught and mu is equal to mu naught. Mu is the parameter, and in alternative hypothesis H1 mu is not equal to mu naught. So there is no difference, and here this is different. So if this is not equal to mu, not equal to mu naught is my hypothesized value, and it means whether the mu either greater than mu naught or less than mu naught. So this an alternative hypothesis is termed as two-tailed test. Two-tailed test. If we specify this alternative hypothesis, like if mu not equal to mu naught, so it means either mu greater than mu naught or mu less than mu naught. So if we take one of this alternative hypothesis, we consider either this one or this one, then this is known as one-tailed test. One-tailed test. So there are many methods which is used to test the hypothesis, and these are the parametric test and non-parametric test. So in parametric test, we just define the population, about the population, that the population distribution is known, and generally we take the population is normally distributed. In non-parametric test, the population distribution is not known. Maybe this is skewed or something else. So just what are the method of parametric test? So we just used T test, Z test, F test, chi-square test, and Anova, and so on. So generally we discuss these are the tests: T test, Z test, F test, chi-square test, and Anova. In T test we test the mean of the sample, and this is generally used for a small sample size. In t-test, we test the mean of the, or this test is applied when the sample size is small, for a small sample size, that is n less than 30. If the sample size is large, then we use Z test for large sample size, that is n greater than 30. F test used for variance test. If we want to test the variance, then we use the F test. Chi-square test is when the variables are category value categorized. So there is some attributes. We want to test the independence of attributes, or goodness of fit, whether they are fit or uniformly distributed or not. So we use the chi-square. So chi-square test is used for goodness of fit or independence of attributes. Independence of attributes. In Anova, if we have more than two sample, if we have more than two, means 3, 4, 5 samples, then to test the mean of this sample, we use Anova. Anova means analysis of variance. So this is generally used for more than two independent sample. Now I start from the t-test. So here this is t-test. In t-test we test the mean. Z test, mean for the small sample. Z test for the large sample. F test for the variance or ratio test. Chi-square test is used for categorical variable, in which we test the goodness of fit or independence of attributes. Anova, this is the when the samples are more than two samples, then we use analysis of variance. These are the parametric tests. Parametric test means the population distribution is known and known to be normal if the population is normally distributed. So we have already discussed what is the normal distribution. If this is the symmetric distribution, this which is about mean, median, and mode. A distribution in which mean, median, mode are equal, then we say that this distribution is normally distributed. Means the graph of this distribution is bell shaped, or you can say the symmetric. Both the shape are identical, and this is the center is mean, median, and mode. So this is the normal distributions. So if the population is normally distributed, then we can apply t-test, z-test, So start from the t-test. T-test. T-test is used for single mean, difference of two means, and pair t-test. Single mean test, if we have a population and we take a sample, one sample. Suppose the population parameter is known to be mu and sample mean is x bar. So if we want to compare this sample mean with this population mean, this is the hypothesis. Any statement about the population, or you can say the mu naught. And if we have just taken the sample and the sample mean is x bar, so if we want to test whether this sample is taken from this population whose mean is mu naught. So if, in this case we have one sample, so obviously this is the one sample mean. So for this test we use t-test for single mean. In difference of two mean or difference of two independent, if we have two population, two independent sample, suppose one sample this and one is another sample is this, these are the two independent sample, and this mean is x1 bar and this is the y bar. Suppose the first sample mean is x bar and the mean of the second sample is y bar. If we want to compare whether these two means are same or different, so in that case we use difference of two means. So these two samples are independent. So whether the mean of this sample, or you can say whether these two samples have taken from the same population or different population. So testing this, we just use the difference of two means. So here there are two samples. In pair t-test, this is the dependent sample, same sample, and we just take the observation in different time. Suppose we have a population and we take the sample. This is the sample and this is the same sample, and we just find its mean, and this is the mean is x bar. After sometimes after treatment, suppose this is the patient sample of the patient, and we just take the observation before treatment, and this mean before the treatment, the observation of the mean before the treatment is x bar, and after the treatment we just after treating this patient, and we again after the treatment we take the reading, and this reading was suppose y bar. So x bar is the sample taken from the before treatment, and y is the sample of the same patient that has been taken after the treatment. So in that case, this mean is the before treatment, this mean is the after treatment. So in that case, if we want to check whether the treatment is effective or not, and whether the difference between x bar and y bar, so in that case the sample is the same but the readings are different time, before treatment or after treatment. In that case we use pair t-test. So difference of two means and pair t-test. Difference of two means the samples are independent, and pair t-test, in pair t-test the samples are dependent, same sample but the observation data are different time. One is before treatment, another is after treatment. So they are two data from the same sample. So t-test for start single mean. Suppose the sample has been taken from the population, and that population that follows the normal distributed. So you can say the sample is taken from the normally distributed population. And t-test for single mean, the formula for t-test is written as mod t is equal to x bar minus mu divided by s under root n. T-test is used when the sample is small and population standard deviation is unknown. If the population variance and population standard deviation is not known, then we can estimate the population standard deviation with the sample standard deviation. So small s, this is nothing but the sample standard deviation, where s sample standard deviation, this is 1 upon n minus 1, because 1 upon n minus 1 is the unbiased estimator of the population standard deviation. So this is x minus x bar whole square. So s is 1 upon n minus 1. N minus 1 is this formula. In that case, the standard s is unbiased estimator. So we have just taken 1 upon n minus 1, and you can say n minus 1 is nothing but the degrees of freedom. So this is the formula for t-test for single mean test, where x bar is the sample mean, mu is the population mean, s is the standard deviation, n is number of observations. So we just take see an example, and the example is ten individuals are selected at random from a normal population, and their height are found to be in inches. This is the height, 63 inch, 63, 67, 68, 69, 70, 70, 71, 70. And 66. So there are 10 individuals whose heights are given in inches, and these are the heights of 10 individuals: 63, 63, 66, 67, 68, 69, 70, 70, 71, and 71. Now the question is, test whether the sample to the population whose average height is 66 inch at 5% level of significance. So just repeat the question. 10 individuals are selected at random from a normal population and their heights are found to be in inches and the heights are given like this. The 10 observation. Test whether the sample belongs to the population whose average height is 66 inch. So this is given that the 10 individuals means number of observation is 10 and this sample is drawn from the normal population. So this is a parametric test and their heights are found to be inch. These heights are given in inch. Now we have to test whether this sample is taken from those population whose mean height is 66. So this is the population and the height of the population, average height of that population is 66. So you can say this is the hypothesis. Given the statement about the population, that the population average height is 66. Now whether this the height of the population is 66, we have taken a sample and the height of the 10 observation is like this. So check whether this sample is drawn from the population whose mean height is 66 at 5% level of significance. Level of significance 5% means you are 95% confident that the population height is 66. So there are 5% chances that your statement will be rejected. So just in that case we have one sample, so we use the one sample t-test, and for the we know that t-test. So first of all we have to set the hypothesis and what null hypothesis. So null hypothesis H naught. H naught is what? H naught is there is no difference between the sample and hypothesis, which is given about the population. So if there is no difference means the average height of this sample and the average height of the population, there is no difference between these sample mean and population mean. So if there is no difference, then we go for the population, with the population. So the whatever the population height is, average population height is given, we just support. So in that case, we just write x bar equal to mu, or you can say mu is what? 66, or you can also write mu is equal to 66. The alternative hypothesis, that mu not equal to 66. So now we find the average height and then use t-test. So this, suppose the height is denoted by x, then we have the formula, and what the formula is? Formula is t is equal to x bar minus mu upon s divided by under root n, where s is under root 1 upon n minus 1 summation x minus x bar square. So just find s, and for this you have to find 1 upon n minus 1 summation x minus x bar whole square. So this is the s. Find x minus x bar and x minus x bar whole square. So what is the x bar? The first sum of x, and this is 678. So x bar will be what? This is divided by 10 and 67.8. So mean, sample mean is 67.8. Now and population mean is 66. So obviously this there is some difference. Sample mean is 67.8 and population mean is 66. Now whether we have to check whether this difference is significant or not. So for this we have to test t-test, and for that x minus x bar, and this is the 23.04 x minus x bar 3.24, and similarly you just calculate x minus x bar again, then squaring this means x minus x bar whole square, then you will get, oh sorry, this is just squaring x minus x bar, you will find minus 4.8 minus 4.8 minus 0.8 like this. So now squaring this, you will get 23.04 23.04 3.24 like this. So now calculating all this calculation. After this calculation, you will get x minus x bar square is equal to 81.6. Okay. Now we just took this of this question, and so our null hypothesis is h naught is equal to, you can say mu is equal to 66, or alternative hypothesis that mu not equal to 66. Mu 66 means sample mean and population mean are same, and this is not. Now our t is equal to x bar minus mu upon s upon under root n, where s can be calculated as s is 1 upon n minus 1 summation x minus x bar square. So now putting the value 1 upon n minus 1, n is 10, so n minus 1 is 9, and summation x minus x bar whole square, this is nothing but 81.6. After calculating this, you will get the value of s is equal to 3.011. So this is the s. Now find the value of t, x bar minus mu. X bar is equal to 67.8 minus mu, that is the 66, and s 3.011 divided by under root n, that is 10. Now after simplifying this, you will get t value of t is 1.89. Now this is the calculated value of t. This is the calculated value of t. Now compare this calculated value with the tabulated value. So the tabulated value is given, and you can also find from the t table, and this is given, and where t tabulated value means t tab, and this is on the basis of alpha, that is the level of significance. So level of significance is 0.05, so t 0.05, and with degree of freedom is n minus 1, that is the 9. So this is given 2.26. This value is given to you, and this is known as tabulated value of t. So now compare the tabulated value with calculated value. If the calculated value is less than the tabulated value, then the null hypothesis is accepted, otherwise we reject the null hypothesis. So in that case, calculated value t is 1.89 and tabulated value of t is 2.26. So calculated value is less than tabulated value. Just compare the calculated value with tabulated value. So here our calculated value of t is 1.89 and the tabulated value which is given to you, this is t at alpha, that is the 0.05, 5% alpha with degree of freedom, and degree of freedom is n minus 1, that is 9, and this is equal to 2.26. So now comparing these two values, tabulated values and calculated values. So if the calculated value is less than tabulated value, then accept S naught, otherwise reject. So in that case, tabulated value t is less than, calculated value of t less than tabulated value. So we accept H naught. Accept H naught. And what is accept H naught? And what is H naught? H naught means null hypothesis. This is accepted. So we accept our null hypothesis, and accepted null hypothesis means there is no difference between the sample mean and population mean. So we can say that this sample has been drawn from the dead population whose mean height is 66. But if you see the sample mean is 67. That is difference. But this difference is not significant. So you can say that there is no significant difference between the, you can write, there is no significant difference between population mean and sample mean. There is no significant difference between the population mean and sample mean. This difference, what we are given, is just by chance. So we just support the population mean. And you can say this sample supports the population. Or you can say this sample has been drawn from that population whose mean height is 66. Now take another example. The mean weekly sales Yes. The question is the mean weekly sales of soap bars in departmental stores was 146.3 bars per store. After an advertising campaign, the mean weekly sales in 22 stores for a typical week increased to 153.7 with the standard deviation 17.2 was, and you can say that the advertising campaign was successful at 5% level of significance. So the question is the population mean. That mean weekly sales of the soap departmental store is 146. So this is given that the population mean is 146.3 bar per store. After an advertising campaign, so there was a campaign, and after completing the campaign, and they have taken a sample of 22 stores, and they found that their average sale increased to 153. So before advertising, the population mean is 146. After advertising campaign, they have taken a sample from that population whose mean was 146.3. So after taking the sample, and the sample shows that the mean weekly sales increased to 153.7 with the standard deviation is 17.2. So whether the advertising campaign was successful or not at 5% level of significance. So before advertising, the population mean was 146. So what is given? So just first of all, we set the hypothesis. So what is null hypothesis? So H naught null hypothesis says that there is no difference. So in that case, you can say that there is no difference between the sample mean and population mean. If there is no difference between the sample mean and population mean, it means that the advertising campaign is not successful because the sample is taken after the advertising campaign. So if the advertising campaign is successful, then it means null hypothesis. And null hypothesis H naught should be rejected. So in that case, first we just taking the null hypothesis, whether it will accept or reject, it will be seen later on. So null hypothesis just says that there is no difference between the sample mean and population mean. So if you say there is no difference between the sample mean and population mean, that is x bar is the sample mean and this is the population mean mu. So you can say it as a null hypothesis that if no difference means such advertising campaign is not successful. So you can also say that advertising campaign not successful is taken as null hypothesis. Alternative hypothesis, you can say x bar not equal to mu, or if not mu and you take just you can take just one tail test. In that case, you can say x bar greater than mu because x bar is 153 and mu is 146. So you can also write x bar greater than mu, and this is the one tail test. So in that case, if sample mean greater than population mean, if the sample mean is greater than population mean, so you can just say that if there is improvement in the sample mean, so it means advertising campaign successful. If advertising campaign is not successful, this comes under null hypothesis. If advertising campaign is successful, it comes under alternative hypothesis. So this is our hypothesis. Now whether we check whether this hypothesis is accepted or rejected. Now, so we know that null hypothesis as t-test. T-test is nothing but x bar minus mu upon standard deviation divided by under root n. And this is given as x bar, the sample mean is 153.7 minus population mean mu, that is 146.3, and standard deviation is 17.2 divided by under root n. What is n? N is 22. Here this is the 22 stores. A sample of 22 stores is taken. So 22 and under root 22. Now after simplifying this, you will get what the value? The value is, after solving this you will get the 9. So t test, this is 9 is the calculated value of t. Now compare it with the tabulated value of t. So what is the tabulated value? So tabulated value is given. So t at 5% level of significance means 0.05 with degree of freedom n minus 1. So there is n is 22. So degree of freedom 22 minus 1, that is 21, and this is given 1.72. So this is the tabulated value of t, and here this is the calculated value of t. Now compare these two, calculated value and tabulated value. So you will see that the calculated value 9 is greater than the tabulated value, that is 1.72. So 9 is greater than 1.72. So with t calculated is greater than t tabulated value. Calculated value is greater than tabulated value. If the calculated value is greater than tabulated value, then null hypothesis is rejected. So this implies that H naught is rejected. H naught is rejected means this H naught, this null hypothesis, this is rejected, means advertising campaign not successful. This statement is rejected. So alternative is what? Alternative is advertising campaign is successful. Advertising campaign is successful. So we have our alternative hypothesis. So you can say that the sample shows that on the basis of this sample we can say that the advertising campaign is successful because the difference between sample mean and population mean is significant. So it's not rejected means difference is significant. So the conclusion is what? Conclusion is advertising campaign is successful. Okay. Now come to the next t-test for difference of mean. Now the t-test for difference of mean. T-test for difference of means. In that case, if we have two independent sample, suppose this is the sample 1 and this is the sample 2, second sample. These are two independent sample, and the mean of this sample is denoted by x bar, and the mean of this sample is denoted by y bar. So why we take the sample? We take the sample to and if we take the sample and study of this sample and find the some estimator, some statistics from this sample, and to this statistics may be generalized for the population. So we generalize the population, that the sample that have been drawn from the population and normally distributed population whose mean is x bar. So generally when we generalize the mean, so we can say the mean of the population is denoted by mu. So from here you generalize the population, that is the mu1, and from here you generalize the population, and this population mean denoted by mu2. So sometimes we just use mu1 and mu2. Mu1 is, this is the generalized for the population, and this is obtained from the sample. This mu2 is generalized for the other population, and the value of this mu2 is taken from the sample. So this is the actual value of sample mean, and when we estimate and generalize, this is also estimator of the population. So the population mean in denoted by mu1. Similarly, the population mean of this sample is denoted by mu2. So in that case, the null hypothesis is what? Whether these two mean is significant or not. So in null hypothesis, what is the null hypothesis for this? Null hypothesis means mu1 is equal to mu2, means there is no significant difference. H naught mu1 is equal to mu2. Alternative hypothesis for mu1 not equal to mu2. And the t-test, t is used, the formula is x bar minus y bar divided by s under root 1 upon n1 plus n2. So the numerator term is known as sampling error always, and the denominator term is known as standard error. So in that case, S will be obtained by the formula 1 upon n1 plus n2 minus 2 and summation in bracket x bar minus x bar whole square plus summation y minus y bar whole square. So this is the formula for standard deviation. 1 upon n1 plus n2 minus 2, because the degrees of freedom is n1 minus 1 and n2 minus 1. So we can write n1 plus n2 minus 2. Summation this. This is the standard deviation. So now come to an example. So take example. The following data related to the height given in centimeter of two different varieties of wheat plants. The following data related to the height is given in centimeter of two different varieties of wheat plant, and this sample is variety 1 and this is variety 2, and the height of this variety plant wheat plant is 63, 65, 68, 69, 71 and 72. The second sample is 61, 62, 65, 65, 66, 66, 70, 70, 72 and 73. Now next test whether the mean height of plant of both varieties are same at 5% level of significance. So there are two samples, and these samples are related to the height of two different varieties of wheat plant. This is the first variety of wheat plant, and the sample size is 6, and these are the second variety of wheat plants whose heights are given like this. So there are two samples, this one and this one. Now in these two samples we have to test what? Test whether the mean height of plant of both varieties are same. Whether the mean height of this sample and mean of this sample are same or different. That is what we have to test. So obviously this is two independent sample because the wheat plant are two different varieties of wheat plant. So variety of 1 and variety of 2. So variety of 1 is denoted by x and variety of 2, the height of the wheat plant of variety 1 is denoted by x and the height of the wheat plant of variety 2 is denoted by y. So the first of all we have to set hypothesis. So here our null hypothesis is H naught, and H naught is what? Means there is no difference between the mean height of this sample and the mean height of this sample. So there is no difference because null hypothesis says that no difference. So first we take no difference. So means the mean of this sample is denoted by x bar. You can say x bar, and mean of this sample y bar. Or you can also take like this, mu1 is equal to mu2, because this sample always generalize the population. So we just take the parameter. So you can write either mu1 equal to mu2. If that both are same means there is no difference. And the alternative one, x bar not equal to y bar. And you can also write either mu1 not equal to mu2. So either use this one, and this is the better way. You should write in this way, because sample is always used to generalize the population. So we just generalize the population, and population parameter is known as, is denoted by mu instead of x bar and y bar. X bar is the sample. So now the what is the formula? And for you, we know the formula is t is equal to x bar minus y bar divided by s and under root 1 upon n1 plus 1 upon n2. And s, and what is s? S can be obtained by this formula, 1 upon n1 plus n2 minus 2 in bracket summation x minus x bar whole square plus summation y minus y bar whole square. Now just prepare the table according to requirement, and you just take x minus x bar whole square, and from here y minus y bar whole square. So just first find the mean. So mean from this summation x and summation y, and the value is, after simplifying this, you will get summation x is equal to 408, and x bar will be what? This x bar is equal to 68. Similarly, summation y is equal to 670, and the y bar, so y bar is 67. Now after simplifying, putting x minus x bar whole square, you will get like this value 25, this is 9, and so on, and here you will get 36, 25. So you can do yourself the remaining calculation, and we just write the result. And the summation x minus x bar square is 60, and summation y minus y bar square is 150. So now putting this value in this formula, and you will get 1 upon n1. n1 is 6 plus 10 minus 2, and in bracket summation x minus x1 square, that is the 60 plus 150. So after simplifying this, you will get the value of s is 3.87. Now just put this value here. You know x bar is 68. So this is 68 minus y bar 67, and s is 3.87 under root 1 upon 6 plus 1 upon 10. Now simplifying this, you will get the value of t is 0.499. This is the calculated value of t. Calculated value of t is obtained as 0.499. Now compare, this is the calculated value. Now compare this with the tabulated value. So what is the tabulated value? So tabulated value is t 0.05 and degree of freedom will be n1 plus n2 minus 2. The 6 plus 10, 16 minus 2, 14. So this is given 1.76. So calculated value is 0.499 and tabulated value is 1.76. Now compare these two and you will get the calculated value of t is less than tabulated value. So what will be the hypothesis? Null hypothesis, since t calculated is less than t tabulated value, so null hypothesis H naught is accepted. Accepted means there is no significant difference between the mean height of two samples. You can say no significant difference between the mean height of two samples. So you just conclude that the mean height of two different varieties of wheat plant are same. There is no significant difference. Because this difference means 68 and 67. This difference is just by chance. This is not significant. Okay. So in this question, what is the conclusion of this question and you analysis that these two samples of wheat plant have the same mean. Now come to the next PRT test. Next is paired t-test. Paired t-test is used for the dependent sample. Means same sample. If you have a sample and the data collected from this sample, that either take the data, there are two data is collected from the same sample. One is taken from, and you can say the before, and after some time you again collect the data. So there are two data from the same sample. So in that case, sample is, there are two samples. One is before and second is after. So in that case, the formula will use like this: T is equal to D divided by D bar divided by S under root N, where D is the difference of sample. Suppose there are two samples, x d bar, you can say x bar minus y bar, and where s can be obtained as 1 upon n minus 1 summation d minus d bar whole square. So where d is the difference of sample, and there are two samples. One sample is taken before, and the another sample is taken after some times. So respondent are same, but the sample are different, and the difference of this sample is known as d. So just take another one example related to this. And also in this H naught null hypothesis is same, means there is no difference between the mean of the sample taken from before and the mean of the sample which is taken after sometimes. So you can just say mu1 not equal to mu2, and alternative hypothesis that mu1 equal to mu2. Now that example, memory capacity of 8 students was tested before and after training. Stayed at 5% level of significance whether the training was effective from the following score. So there are 8 students and the table is given. This is the student and their memory capacity before training, and memory capacity after training. So there are 8 students and their memory capacity before training was 49, 53, 51, 52, 47, 50, 52 and 53. And after training, the memory capacity 52, 55, 52, 53, 50, 54, 54 and 53. So these are the memory capacity of the same group of a student that was taken before the training and after the training. There are 8 students and these are the. So now first we have to set the hypothesis. So what is the null hypothesis? H naught means average or mean capacity, average memory capacity of the group of 80 students before training and average capacity of the student after training is same. There is no difference between the mean memory capacity of these two samples. So mu1 not equal to mu2. So if there is no difference, average capacity of the student before training and after training, if there is no difference, it means what? So you can say if the before training and after training there is no difference, so it means training was not effective. So you cannot say it means training was not effective. Training was not effective. Alternative hypothesis means mu1 not equal to mu2. Or you can say if the training effective, so in that case it will be better to write if the training is effective. This means the average memory capacity of the student after training is better than the average memory capacity before the average memory capacity of the student before the training. So mu1 less than mu2. This is one tail test. If the means training was effective. If the training was effective, then there must be some improvement. Now the formula for this, and this is what? T is equal to D bar divided by S upon under root N. So what is D? Suppose the memory capacity before the training is denoted by X and the memory capacity before, after the training is denoted by Y. So D is X minus Y. So difference of these two before and after. Now find D square. So here S and S can be obtained by just using this formula 1 upon n minus 1, and this is, you can write summation D square minus n d bar square. You can simplify this. So in that case, you just find the d square and ds. If you take d means difference of x y, then you will get like this: minus 3, minus 2, minus 1, minus 1, minus 3, minus 4, minus 2, 0. Now squaring this, so this is 9, 4, 1, 1, 9, 16, 4, 0. And sum of this means summation d square. This is equal to 44. Now first find the standard deviation. So this is 1 upon n minus 1. N is 8. This is 7. And this is summation d square. Summation d square is 44 minus n d bar. N is equal to 8 and d bar. What is d bar? D is the, what is d? So sum of d, and this is minus 16. So d bar is equal to minus 16 divided by 8. This is minus 2. So mean of d is minus 2. Now putting the here, this is 8 into d square, this is the 4. Now simplifying this, and you will get the value of s is 1.31. So now putting the value in t, and you will get t is equal to minus 2 divided by 1.31 under root 8. After simplifying, you will get the value of t is 1.9. So this is the calculated value of t. Now compare this calculated value of t by the tabulated value of t. So what is the tabulated value of t? So just tabulated value of t at 5% degree of freedom, that is the 0.05, and 5% level of significance, and the degree of freedom is n minus 1, that is 8 minus 1, that is the 7. So this is given 1.9. Oh, sorry. Yes, 1.9. And this is not here, calculated value is not 1.9, but this will be, after simplifying, and you will get 4.3. So the calculated value is 4.3 and tabulated value is 1.9. And this is, now compare these two, calculated value with tabulated value. So calculated value is 4.3 and tabulated value is 1.9. So obviously the calculated value of t is greater than, so just write here, calculated value t is greater than tabulated value of t, then the null hypothesis H naught is rejected. So we conclude that this null hypothesis is rejected. So we reject the null hypothesis, means we go for the alternative. And what is the alternative? Mu2 greater than mu1. So alternative hypothesis, we accept the alternative hypothesis, and this is what? This is that the training was effective. So we conclude that there is significant difference between the average memory capacity of the student before training and the average memory capacity of the student after training. The significant difference. So this means that there is significant difference, and that is the training was effective. So you conclude that the training was effective because there is significant difference between the average memory capacity of a student before training and the average memory capacity of the student after the training. Okay. Fine. So now next we come to another test and come to the chi-square test. Now the next is chi-square test for goodness of fit. Chi-square test for goodness of fit. Chi-square test generally we use for categorical data, and in this case, goodness of fit if that whether the distribution is uniformly or not. What is the in chi-square test for goodness of fit, we just compare the theoretical observation with the practical observation, or you can say that observed data with observed data with estimated data. Suppose, for example, we want to toss a coin. If a coin is tossed 10 times, if a coin tossed 10 times, so according to theory says that there will be, what is the output of a coin? Head and tail. And according to theory says that the head will be 5 times and tail will be 5 times, because these two are equally likely event. So according to theory, there will be 5 head and 5 tail. This is based on theory. But if you just go for the experiment, and maybe there will be a result, h is equal to 6 and suppose tail is equal to 4. So this is the estimated and this is observed. What is estimated and what you have observed. So there is some difference between estimated and observed. So on this observed data, whether we can support this theory or not, this is our question. So in that case, we use chi-square test for goodness of it, because the theory says there is we want to compare between the theoretical data and observed data, or you can say in theoretical data as an estimated data. So just for example, the tossing a coin 10 times, according to theory says there will be 5 head and 5 tail. But if you do this experiment, and maybe you get some other result, and this is head 6 times and tail 4 times. So there is some difference between this observation and this observation. So now test whether this difference is significant or not. So for this we will use the chi-square, and the formula is, for chi-square the formula is what? O minus E square divided by summation E. So this is the formula, observed minus expected. So the observed, O for observed, E for expected. Divided by expected. And null hypothesis same, H naught, null hypothesis H naught, you will tell no difference between the observed and expected. Alternative, there will be difference between observed and expected. So just see one example and then we will conclude. The following table gives the number of accidents that took place in an industry during various days of the week. Test whether the accidents are uniformly distributed over the week at 5% level of significance. So here the data is days and number of accidents. Sunday, so the days start from Monday, Tuesday, Wednesday, Thursday, Friday and Saturday. The number of accidents is 16, 20, 14, 13, 17 and 16. Now the question is, the following table gives the number of accidents that took place in an industry during various days of the week. Test whether the accidents are uniformly distributed over the week at 5% level of significance. There are 6 days and the number of accidents that took place in an industry. On Monday 16 accidents, Tuesday 20, Wednesday 14, 13, Friday 17 and Saturday 16. So this accident distribution of the accident are whether distributed uniformly or not. So we know that the number of accident doesn't depend on the date, so there must be equally distributed. So in that case, this is the observed data. What is observed in a typical week? So according to theory, this should be what? If the total accident in a week, how many accidents? There are 96 accidents in a week, I think. Total accident is 96. So there must be equally likely, equally distributed. So each day there will be, according to theory, there will be 16, 16, 16, 16, 16. Every day there should be 16 accidents. So according to theory, because the total accident is 96, so on average each day there will be 16 accidents. But in observed, what is observed? Observed is that on Monday there is 16, Tuesday there is 20 accidents, Wednesday 14, and so on. So this is the estimated value and this is the observed. So this is the observed and this is expected or estimated. So in that case, we just see here what is the null hypothesis. Null hypothesis is that there is no difference between the expected and estimated. So just we so according to null hypothesis, H naught observed is equal to expected and alternative is observed not expected. So in that case, we calculate the chi-square, and in chi-square we find O minus E, and this is a square of. So using this, and you will get difference square of this difference 0, this difference 4, 16, this difference is 2, 4, this difference is 9, this difference is 1, and this difference is 0. So sum of this, so we just write here. So the formula of chi-square is summation O minus E square divided by E. So this is what? Summation O minus E whole square, and this is equal to 30. So if you add this, so this will be 30. So just 30 divided by E, because E is expected value are same. So this is 16 and 30 divided by 16, and this is 1.87. So this is the calculated value of chi-square. Now compare it with the tabulated value of chi-square. So in chi-square, we find the tabulated value like this. This is chi-square with degree alpha level of significance into n minus 1. N is 6. So here n minus 1 5, and this is given 11.07. So this is the tabulated value and this is the calculated value. So calculated value is less than tabulated value. So chi-square calculated less than chi-square tabulated value. So what will be happen? H naught is accepted. So we accept the null hypothesis. And what is the null hypothesis? Null hypothesis is there is no significant difference between the observed data and expected data. So this sample support to our theory. So there is no difference between the observed data and estimated data. Okay, so now we stop here, and if you want to ask any query, then you may ask. Okay, so stop here. Thank you.